In this video, we're gonna talk about how to evaluate definite integrals. So let's talk about the difference between a definite integral and an indefinite integral. A definite integral has a lower limit of integration, in this case a and b, in the upper limit of integration. An indefinite integral does not have that. So this is an indefinite integral and this is a definite integral. The antiderivative of a function f of x is capital F. To evaluate the definite integral, once you find the antiderivative, you need to plug in the limits of integration, and so the value of the definite integrals is going to be f of b minus f of a. But let me show you the process by which we can evaluate a definite integral. So let's start with this example. We need to find the entire derivative of each term in this expression. What is the entire derivative of 8x cubed? Well, let me give you a review first. The entire derivative of a variable raised to a constant is going to equal that variable raised to the constant plus 1 divided by n plus 1. Now, for indefinite integrals, we would have the constant of integration c. But when dealing with indefinite integrals, you don't need to worry about c. So as an example, let's say if we want to find the entire derivative of x to the fifth, all you need to do is add 1 to the exponent. It's going to be x to the sixth and then divided by that result. So let's say if we want to determine the entire derivative of 4x to the seventh, so we have a constant time x itself. First, we write the constant and then find the entire derivative of x to the seventh. So add 1 to the seventh, that's 8, and then divided by that number, and after that you can reduce it. So 8 is 4 times 2. We cancel the 4 answer. The answer is going to be x to the 8 over 2. So that's how you could find the entire derivative of monomials. Now, let's continue on with this example. So to find the entire derivative of 8x cubed, first, we're going to rewrite the constant 8. Then, we're going to add 1 to the exponent. 3 plus 1 is 4, and that we're going to divide it by 4. Now, let's repeat this process to the next one. So, the antiderivative of 3x squared is going to be the constant. 3 times x raised to third power divided by 3. Now, what about the antiderivative of 6 times x? If you don't see a number, it's always a 1. This is 6 times x to the first power. So, just like before, we're going to rewrite the constant 6. And then the variable, add 1 to the exponent 1 plus 1 is 2 and then divided by that result. Now, as what mentioned before, because we're dealing with a definite integral, we don't need to write the constant c here. But we need to write our limits of integration. So now let's simplify this expression. 8 divided by 4 so is 2. So we have 2 times x to the fourth. 3 divided by 3 is 1. So that cancels. So we have 1x cubed, which we can write as just x cubed. 6 divided by 2 is 3. So then this is going to be plus 3x squared. Evaluated from 2 to 3. So now this is going to equal f of 3 minus f of 2. And keep in mind, this expression here represents lowercase f of x, and this expression is the derivative which represent capital F of x. So we're going to plug in 3 and 2 into capital of x. So in these brackets, we're going to put f of 3, and here this is going to be f of 2. So let's plug in 3 into this expression. So it's going to be 2 times 3 raised to 4. Raised to 4th power plus 3 raised to the 3rd power plus 3 times 3 squared. Now, let's substitute x with 2 in the second set of brackets. So, we have 2 times 2 to the 4th power plus 2 to the 3rd plus 3 times squared. So, this is f of 3 and this here is f of 2. So, at this point, we just need to do the math. 3 to do the 4th power is 81. And so, 81 times 2 is 162. 3 to the 3rd is 27. 3 squared is 9 times 3, that's 27 as well. 2 to the 4th power. If you multiply for 2, you're gonna get 16. That's 16 times 2 is 32. 2 to the 3rd power is 8. 2 squared is 4 times 3, that's 12. 27 plus 27, we no longer need bracket anymore. Oh, we no longer need bracket anymore. So, 27 plus 27 is 54. 32 plus 8 is 40, and 40 plus 12 is 52, so this is minus 52. 54 minus 52 is 2. 162 plus 2 is 164, so this is the value of the definite integral. Now, this value here, 164, represents the area under the curve, that is between the curve represented by that function on the x-axis between the x values 2 and 3, so that's what the definite integral can do. It can help you calculate the area under the curve. So that's it for this video.